Okay, so in problem K, kitchen combinatorics, we were asked to help chef figure out in how many ways he could make a dinner. So to make a dinner, he had to first choose a starter dish, and each dish had a list of ingredients. For instance, dish 1 maybe had the ingredients 1 and 2. Then there was a main course, same format, and some desserts, also in the same format. For each ingredient, there were a number of brands of that ingredient, and using a different brand would lead to a different type of dinner. So, to take an example, if the chef chooses to use starter number 2, and main course number 1, and then the dessert, then the list of ingredients that he needs to get are ingredients 1, 3, 3 is already on our list, 4, and 3 is already on our list. So we need to get 1, 3, and 4. So then we look at the table of ingredients and we see that 1, 5 possibilities, 3, 11 possibilities, 4, 13 possibilities. So there are 5 times 11 times 13 different ways of making the dinner by choosing this specific starter, this specific main course, and this specific dessert. So then we simply loop through all possible starters, mains, and desserts. There are only 25 of each of them, so there's 25 cubed, which is very small possibilities. Additionally, it could be the case that there were some conflicts, so some dishes didn't go well together. So for instance, if the first starter doesn't go well with the second main course, then we will skip computing the product for that combination of dishes. And then we simply add up the results for all of these different, add up this product for all of the selection of a starter, a main, and a dessert. Then there were pitfalls that you had to check if the answer was larger than 10 to the 18, and if so, say that there were too many possible choices. And if you just do this, there are many ways to fail with this by getting overflow, because it's at the limit, close to the limit of what a 64-bit integer can contain. So there are many ways around this. You can either use big integer in Java, or you can compute an approximate answer using floating point values to check if it's really far above the threshold, and if it's not far above the threshold, you can compute it exactly using 64-bit integers.